Hello and welcome to the demonstration of project. It's about two energy companies with two plants each of them. The companies have at company level two user classes. One is the user class with limited permission, that's called operator, which has access only to plant data and not to the financial data. Another class of user has full access, that's called admin user, and it has all the company data access. It's financial data plus plant data. Plant data is about the elements available at the plant. These are essentially the equipment installed there, and also the time series data and data sources from where we get the time series data records. And this project is going to be generated by AI agent using GPT-5 model as requirement, and LangChain deep agent is going to be used. Deep agent is the concept where we have a main agent to take care of our requests and instructions and delegate the specific functionalities to be taken care of by sub agents or functions or tools by the means of function calling. And yeah, these are some other requirements and guardrails to be taken care of. Let's go to demo, and this is our application. It has simple web UI. Let's log in with admin user of company 1. This is the view we get when we log in. Here we provide the plant name, plant 1 or plant 2. C1 stands for company 1 here. We require financial data or energy summary, refers here to the plant data. It's about time series records, and over that we are going to make data analysis. Start date, we have data available for March and April 2026. So let's try with 1 March 2026 up to 2 April 2026. Run analysis. It shows the data on the screen, and using that we can create documents. Create document. As we can see here, the document has been generated with current date and time. If we check time here, it's about 9:30. My laptop has a difference of 2 minutes, sorry for that. We can download the file, we can view that file very well. Suppose I save that under my a learning directory, not a problem. Quite nice of a selection. These are the plant data analyzed during this duration. Total energy kWh is 196956 kWh. Power peak is 1204. Average irradiance, module temperature, and other stuff. Okay, cool. So these are two main functionalities, and we have taken care of that. Users from company 1 cannot access data from company 2, because here we can select only plant 1 or plant 2 of company 1 when we are logged in as a user from company 1. Let's log out and now log in with company 2 again. For simplicity and demonstration, I have kept very easy password here, easy to guess, but not for production. It's not nice. So when we are logged in as a company user, it's showing C2 as company 2 coding, 001 is plant 1, 002 is plant 2. Again, it's admin user, so it has both options available. Now let's go to implementation to keep the video and demonstration quite short and concise here. So from this web page I copied most part of the problem statement and removed some instructions about submission and such discussion and further evaluation, but the most part contains requirements and guardrails. These are kept here very well. Requirements 1 2 3 4 5 6 7, including the limitations, safeguard, safe agent access, and the safety must be provided. So the agent is provided permission to execute code, and this is unsafe for the environment. For that, sandboxing is required. That's a must. Now let's go step by step, not randomly and so flexibly. This is problem.md file in my project directory. This is going to be fed to agent system for creating project, but before that let's define the persona of agent. Our agent is a software engineer at expert level, specializing in FastAPI and REST API design. These are its capabilities, and what I expect from the agent is a project structure with these directories: API for the source code about routes and DB schemas, services to contain source code, implementation of business logic, models about modeling data between objects and database and dictionary. Schemas are pydantic models for validation, and code about taking care of cross-cutting concerns. One more file is added to supplement this agent persona, that's agents.md. This is specific to this particular project for the agent to be used for the use of agent. Use UV for packaging system and for registration. And every time some change is made in source code or configuration, make sure to rerun the test suite. Now we have seen project demonstration. Project creation has started with program.md, and input data which was provided here, data.zip, has been extracted into a directory called data. It contains data about both the companies. For both the companies, this contains specifications about APIs as well, that whenever we query on the data about companies or plants, this should be the format of request, and these should be the URLs of our REST API. Here one thing to note is that it's not small p, it's not plural as plants as expected in most of the APIs by standard convention. So we'll take care of this later on in a little bit. First of all, we got ready with agent persona. It says the role definition and audience and tone of the text output from agent can be defined here, along with the objectives, and guardrails provide for boundaries and constraints so that agent drift is not happening, because that's very catastrophic if that happens. To provide access to our API, we got the actual API key and place that into our environment file here, and we also specified that we are going to utilize GPT-5 for code generation, testing and deep thinking, and that is provided by the vendor OpenAI for us. This is our choice. We can change it as well whenever required. Now next, I instructed the agent to generate implementation plan in the format of ADRs and C4 diagrams. These two are very important and defines the path of how agent is going to think deep about project, what decisions it makes on the behalf of programmer For example, in case of any technical debt, what to take forward and what to reject or put on hold. These documents and diagrams direct and assist the agent with those concerns. So ADR full form is architecture decision record. These contain most of the requirements and what decisions we take around those requirements. So first requirement, let's say, is about tenant isolation. Ideally there should be two databases created for two different companies, but that will be quite huge and complex to take care of, considering the 1 day time limit, 24 hours time limit. So for now, what decision has been taken, single database is going to be created, and data will be ingested from the input data files into the database. And how we are going to distinguish the data records across companies? By the company ID field, and that's quite simple, and this is okay for querying our data system, but for production level implementation, again, different databases are to be created for separate companies. Now ADRs contain essentially the goals are the requirements and purposes for which the agent is going to work on the project. I don't know why again it's happening. Sorry. Let me just close that tab together. Here it is. So for now we take decision to have a common database for both the companies, and these are the alternatives evaluated, and I'll state further about what's not taken into consideration or implementation right now and can be taken care of later on. In the second ADR we have the schemas for data ingestion into database. These particular schemas will be created, and in parallel database tables are going to be created by the agent. As I observed, the tables are not so efficient. They have some columns with duplicate values, so I removed few columns of the tables. Those table columns are, for example, let me see my notes. There was one data source ID in data source table. I have removed that. Another example is about environment parameter JSON, something like that. In plant table, I have removed that, and I have added is active field to users table, because only active users of a particular company are going to be permitted to perform data analysis. Inactive users or expired user accounts are not to be allowed, and that's a major change. And yeah, we can also modify our indexes. For example, in market price, we can rely our index upon, we can anchor our index upon company zone and timestamp. These are few examples which we can take care of in respect of data models. Now to agent execution. Execution is about code execution. It's very risky to its environment or say closure. So any code execution performed on behalf of agent is going to be in a sandboxed environment. So that sandbox is created, code is executed, results are displayed, and the sandbox is destroyed. That's a safety practice similar to temporary containers. But for single implementation, we have utilized sandboxing, and for production level implementation, we are going to utilize Docker or Podman containers and orchestrate them very nicely to ensure high availability of our services and security across code execution instances. Background runs is slightly correlated, but it's more about user experience. For example, user should have capabilities to request multiple agent runs for data analysis or document generation, and these should go on continuing in background. User can navigate away from the web page when we have multiple pages or views in our application, or user can simply press refresh button to refresh the page, and that refresh must not halt any under process run of the agent. That run execution should be continued and complete to a positive outcome or error. This has been accepted and taken care of. Document generation, three different types of documents are to be generated: Word document, spreadsheet, and PDF document. This is README, which summarizes the ADRs, and in correlation to that we have C4 diagrams. C4 diagrams are about context, containers, components, and code. By code we mean source code here. So in first place we have context, what this project is about, what's the usage scenario from end user viewpoint. User interacts with UI, that's web UI, simple web UI we have created here. UI delegates the request to API, but between these two there is authentication. Active users of respective company is allowed. No other user is allowed to perform data analysis or document generation. Then API forwards the request to stream if we are capturing the data from stream as time stream, that may be real time. Then API sends request to agent. Okay, work on this request, I don't know what to do of it, decide yourself. Based upon that, if it's about fetching data from database, agent connects with database. If it's about generating files, it connects to files tool and delivers the results. Second thing here is containers. Containers are what different containers are working together very nicely in the format of flowchart. And for this flowchart we have many options to utilize. One is flow.io, but I used Mermaid because I find it quite easy. That's a nice choice. In textual format we can describe the flow diagram and copy it very well, and we can also add it to SCM. That's the choice made by me, why I go for Mermaid in this scenario. Browser, from browser API is hit. I mean, within browser our simple web UI is there. It may be a single page application using Streamlit or React. So that hits our API. API is the entry point for the backend that connects with our tenant. Tenant is single data source for particular company, but here we have common database, so it's a common database, but in production it will be single company database. API in parallel connects with chat, accepts query and instruction from chat UI. API in response to the chat request. Uh, can connect to stream as well whenever required, and goes to agent orchestrator. Orchestrator tells agent, okay, start working now. Agent, by the means of function calling or called tool calling, employs various tools if it's required to fetch data from DB. It invokes DB tool, if not, then not. Sandboxing for code execution, store for storing the generated files. Then again, orchestrator connects our agent to language model, that's a large language model. GPT-5 is very nice for coding and deep thinking. This is useful for deep agent. API lists the background jobs in the format of background job state, that these jobs have been completed with positive outcomes or error messages. Next to containers is components. Components about agent. Agent has the following tools to delegate activities to: query tool to query on database, code tool to code execution, doc tool for generating files. Next we have code thing that we can see in our application code. But before that, let's see this file again. Flow. It shows some sequence diagrams, for example, in the UML format, as we remember from older days and decades. But again, it's here in the mermaid format, so as to make it easy to read, to be read by agents and other automaton, as well as by humans, and also fed into SCM and ingestion to some systems of automata. This is again a common readme over C2 and ADR documentation. Requirement coverage. Data ingestion has been taken care of. Users, roles and tenancy, about security and permission, agent behavior and code execution. This is about sandboxing, and safe agent access is about similar thing. If you are going to have any document generated, that's going to be linked and provided to download here. This page has been we have logged into company 2 admin, as you remember, but in company 1 we had created one file today. So company 2 is showing only older documents. This is a requirement that documents should have a security constraint per company, per user and per agent run. So that's taken care of very well. We are happy about that. Background agent, this can be demonstrated when we hit so many commands. I have tested that while implementing. Document output. What document formats are allowed? 3 document formats. We have allowed 4 output. Now again, to save on time, let's go to code. This when I was happy with the implementation plan, which I was not initially, I have made some modifications in database schemas. Upon that, having made those changes, I was happy with the implementation plan. Then I instructed the agent to go further and implement and execute the implementation. This was this was the starting point with problem MD, data directory and API key for Windows. Design architecture for the project, including ADR and C4. This we have already discussed. Now, which documentation level you want? Lean, very minimalistic, but I was not happy with that. I'm a detail-oriented person for some objects, because this documentation is very important to start with. If it's gone wrong, then will miss many days of hard work and agent tokens. So I went with full package. It provided ADR plus C4 and flow nodes in the format of Mermaid data flow. This was the choice made. Yeah, formal ADR with all things are provided, and now as the fourth item of C4 code is generated. This is the code generated. in.py is about directory and main.py as a starting point. Models, these are database models. As we see here, we had extra data source ID. I have removed that. In other tables as well, I have made some changes. Now I reviewed the implementation plan and instructed the agent to implement that, and this source code was generated along with the database schema. We have configuration files, how to connect to our database, where database is, and in API we have routing and general instruction about API. These are the routes created and simple web HTML for that. I have not worked much about error, but differentiated distinguished error responses may be defined here to be realized. This is about authentication and user security and data security. Now next point is about now that the code has been generated, I requested the agent to go and test the generated application by executing its code, and many negative scenarios were already taken care of, but still I made sure to add few more of test cases which are negative. So all in all we have these. Operator can query readings, admin can list plants, cross company access is blocked, invalid date range is rejected. So many of the negative scenarios have been taken care of. I am happy about that. And whenever some code change was there, test scenarios were being executed again to check for regression. One point here to make note of is that agent asks for some permissions to execute shell commands or to execute the code out of our application, and it provides options as apply always, do not apply, run always, do not run. Here I recommend to go with apply and do not apply, and run and don't run. Only these formats of options to go with. Not nice to go with apply always or run always without further asking, because in that scenario agent will be more of automated and self-directed, and that's a starting point where we allow agent to go and deviate far from its intended behavior, and thereafter it will be very difficult to tame it again, because agent will have some size of memory. By memory we mean collection of previous chats and dialogues, and when one deviation starts, then agent starts behaving and drifting further into that direction. If that direction is wrong, the agent is going to be more and more into wilderness. So to keep the agent well directed, well focused. Allow always should be avoided. And furthermore, we can time to time revise Copilot instructions and agents.md files. And when it is very much necessary to get the hanged agent out of its memory and hallucination, then we may take a hard decision of deleting the existing active memory. Let's start with fresh memory and Copilot instructions plus agents.md. This is very powerful technique to take agent back on track. Next, when we were satisfied with the API along with the negative test scenarios being tested well, I instructed the agent to generate a light web UI. It generated that in React for me, React.js, and then again I tested the app, but now I tested it using the web UI. It has done very beautiful job by providing me such a usable and comprehensible web UI. I really appreciate that. I had to only change the color theme. Earlier it was colors with very high contrast. Maybe nice for people with vision problems, for accessibility, but to start with, let's have some light colors. It should not be very bright or very dark colors in the beginning. We can always change the color themes again whenever required. So I tested many scenarios of performing data analysis, displaying the analysis results in the form of JSON on web UI, and generating documents. And this is one document from that day. I'm not sure if it links very well to its URL now. Let's go for it. To my learning directory again. Okay, it's a while check. The link is still valid. Wow. So without further hardening or fostering, this feature can be migrated to production. Can be released very well. So nice. That's a cherry on the top of cake. Back to IDE. Now I can illustrate what has not been done and what should be done as best practices and for production level of release. We can utilize a specialized database system for time series data. One such example is ClickHouse, that's quite popular in the market now, and is being open source. It has quite wide user base, so it can be utilized. There are other options as well in the market, but I'll give first try to ClickHouse, and we can normalize RDBMS further to optimize it for queries as well as data ingestion, because for single day we have done with a simple table structures around entities and no join tables or such complex stuff as we do and manually take care of traditionally in the case of ORM or OXM, to be more general. Very important and must in this age, use containers. with the facilities of Docker or Podman or any other vendor, maybe Rancher, and orchestrate the containers very well using Kubernetes or OpenShift or the Rancher facilities from SUSE. Implement observability very well, and we must not take it lightly, because observability gives us quick view into how our agents are performing, how well they are aligned with business goal, generating nice value for us, and how far have they already drifted or deviated from desired path of execution and KPIs. Yeah, KPI is a term which was earlier used for only for humans, but now it makes sense to use the KPI term for agents as well, as they are our new age workers. What more? Let's check in ADRs. Back. Tenant isolation has been taken care of. Data model. About agent execution and background runs. Agent execution is quite well sandboxed now, but Dockerized in production level of release. About background runs. For this, I recommend using an external queue system. So whenever a run is requested, whenever an execution is requested, that should be fed into a queue system, and queue system will hold it until it's fetched from any executors or orchestrator to be executed actually. And in this way, multiple agent runs can be taken care of simultaneously if we have more than one course, which is a quite common scenario nowadays. Those runs can be executed really in parallel, in single word, concurrently. That will boost performance manifold. That's a very nice improvement for production level, and KPIs to be kept very well satisfied and fulfilled, and we will have very nice numbers around SLAs. Few more points. For production, LangGraph should be used for streaming, checkpointing, and further training of our agents and models. And in agent builder there should be some best practices taken into account while building agents. As a programmer, I should be more explicit while giving instructions to agent, and also while defining the role and responsibilities and even guardrails to the agent. I should not think, okay, this is obvious, agent will refer it or render it from something. No, we should be quite explicit about that and provide explicit instructions and constraints to the agent, and whenever required, I should provide an example thereof. Okay, suppose if I were working on a sales application, I would have done this activity in this format. Try to replicate this pattern out of this example for my data analysis project. And whenever any major change is done in architecture or business requirement related code fragment, again test the application across the whole test suite because testing for regression is very important. Regression must be removed and fixed right in the beginning, in the first instance. And yeah, as we are in a conversation with an entity, which may be a human, which may be an agent, or multiple agents, multiple humans, or a mix thereof, so we may forget many quick steps and changes. So we must make notes about those changes and amendments in the form of documentation, and this log of changes, this change log should ideally be added to SCM as well, so that other programmers and agents can reference it and see what has already been implemented and what's the current state of project, without scanning through the whole source code in first place. And again, about the agent execution and data model, and partly about document generation, but not necessarily. The output of the agent must follow a very clearly specified schema. It can be defined in the format of JSON schema as well. If that's a text stream, if that's a Word document, Excel spreadsheet, or PDF file, or JSON document, or CSV file, or any other format which may be required in business scenario, that should be very clearly specified. All in all, yeah, I'm satisfied here with the delivery of this demonstration and design decisions along with future considerations. As a closing note, I would like to say output schema and other such things, if these are taken care of very well, we will have a very nice agent tested on real world data to provide very realistic results along with the constraints of real environment and scenario. So it's about business data as well as performance. Synthetic data, which is similar to real business data, but synthetic data we can have in very large amount, we can say huge actually, to test again for future scenarios which may be rare, but which are nice to predict and test beforehand, and adversarial data for negative testing, so that whenever there are some attack pathways or some vulnerabilities happening in future, our agent is very well vaccinated to cope with that. Yeah, thank you for being with me during this demonstration. I hope it's informational and comprehensible. If still there are any open questions, I'll be happy to answer those in discussion sessions. Thanks again. See you soon.